So next is testing of isolators and circuit breakers. So the next electrical apparatus is isolators and circuit breakers. So basically, this test on circuit breaker will be done based on the construction and operation characteristics. How the constructions are done, based on that the testing will be done, and how the operation of this isolators or circuit breaker will be done. Based on that, once again the test will be classified, and also electrical characteristics of a circuit where your switch or your circuit breaker will interrupt to make or break the circuit. So how the electrical characteristics will behave there. So these are the basic tests we need to perform on a isolator or circuit breaker. Isolator, circuit breaker, both are same. So isolator are nothing but which manually opens or automatically which can open or close a group of switches, right? Group of lines. All the three phase will get connect and get open simultaneously by opening your isolator or closing the isolator. Similarly, circuit breaker where whenever the fault will be sensed by the relay, which will give a trip signal for a circuit breaker, and hence the circuit breaker will operate here. Once again, it will break or make the circuit. So the test which will be performed on this are, the first one is the dielectric test or over voltage test, temperature rise test, the mechanical test, and short circuit test. This involves all those characteristics: constructional, operational, electrical characteristics. So we'll see one by one what happens in the first one. The name itself is saying it's a dielectric test. Obviously, which we need to check the what is the whether it can withstand the dielectric strength or not. Right? That is the main important here. So here, the over voltage withstand test of a power frequency, lightning and switching impulse voltage will be done. So it has to withstand, your isolator insulator has to withstand the dielectric test with respect to the power frequency, with respect to lightning voltages, with respect to switching pulses or switching surges also we can say. So it will be done with this respect to this test here. And these tests are done for both internal and external insulation with the switch or a circuit breaker in open and close or closed condition. So they will be doing this test for internal and external insulation. So within the internal part of a circuit breaker or external part of a circuit breaker or isolator, only external part. So with respect to when the switch has been closed or switch has been open, are both open and closed position. So the test will be done based on this condition. If the circuit breaker or your isolator is in open condition, then the test voltage levels are 15% higher here. If it is a open condition, the test voltage levels will be 15% higher than the test voltage. And if it is a closed circuit, then the test voltage will be less than the your applied voltage if it is in a closed position. So next one is, so within this we have one more test which is called as impulse test. Already we are aware of that impulse. What is impulse? So with the lightning impulse waves of a standard wave shape, once again with a standard wave front and standard wave tail of a similar manner will be applied for which has been used in a insulators. The same test will be performed here for a impulse test. In addition to that, the insulator test in isolator and circuit breaker. So what they do here, they perform under over voltage due to the switching operation. They perform under over voltage test also. What happens if the voltage falls down under the maximum voltage? That test will be performed with respect to the same test which has been performed in a isolator. The next one is the temperature rise or as well as a mechanical test. So these are the tests will be done on a circuit breaker and are done according to the specification. If you take any circuit breaker or any isolator, on that it will be given it can withstand a maximum temperature, say 1000 degrees Celsius. or anything else, right? And what mechanical stress or what mechanical load it can withstand. So based on the specification, these two tests will be performed based on the specification. The last one is short circuit test. So very important that usually where we come across the fault in a power system. So here the short circuit test is the most important test we can say, which will be carried out on the circuit breakers. It will be carried out on the circuit breakers. So since these tests are primarily performed on the devices that are able to safely operate or safely interrupt the fault current. So in the next semester we'll be studying in detail about this circuit breaker, how the fault occurs, how the circuit breaker will operate, how what happens with the circuit breaker trying to isolate your faulty system, what happens within the circuit breaker, why this SF6 gas or nitrogen or air blast circuit breaker, within air blast circuit breaker we make use of air over there or any nitrogen, what is the use of these gases within a circuit breaker. So all those detail will be studying in the next semester. We have a power system protection subject. There will be studying in detail. So this test consists of determining the making and breaking capacity of a various load current. So obviously circuit breaker is meant for you're making the circuit, nothing but closing or breaking the circuit. It is a open the circuit or close the circuit. So this will be tested for a various load current. So different types of load will be applied, and based on that the load current will change, and also with respect to the rated voltage also. Load current and rated voltage test will be done. So in this case, where if we make use of isolator, if the short circuit test will need to be done on an isolator, so the short circuit tests are conducted only with a limited purpose to determine their capacity to carry a rated short circuit current, whether it can able to carry the rated specific short circuit current or not. They will check only that parameter with respect to the isolator here. So in this case, no breaking or making current tests are done with respect to isolator, because it is not meant for automatically breaking or automatically making or breaking here. So only circuit breaker will be done opening or breaking based on the fault. Isolator, it will be done manually, right? So that manual closing of the switches can be done automatically. That will be mainly based on the input given by the person who is operating or who is maintaining the subsystem or substation. Okay, that is the thing here. So this is regarding the testing of isolator and circuit breakers. So there are different methods of conducting short circuit test, because short circuit test is very, very important with respect to your isolator or with respect to your circuit breakers. So very, very important is short circuit test. So based on that, there are two types of tests which you perform on an isolator or a circuit breaker to determine the short circuit test. So first one is direct test and synthetic test. These are the two tests. So in the exam point of view, under the synthetic test, we have 5 more. We have 4 more, which is given the next slide here. Yeah, synthetic test basically 1, 2, 3, 4, 5, as well as these 2. 7 tests are there under synthetic. So in this, the very important test is synthetic test of a circuit breaker. Is the third one. So which will be seeing over here. This is a diagram for that test. So very important, as well as this one. Very, very important test. We'll see that in detail how it will be done. So we'll go first one. So what do you mean by this direct test? So the direct test once again subdivided into 2 types, which is using a short circuit generator as a source, using a power utility system or a network as a source. So the test is done normally with respect to the same case which I already explained in the previous one. So only thing, the source for that doing the test will be made use from a generator or from a your network source. That's the only one difference in a direct test. So that's the reason the name is said as a direct. I'm taking a supply directly from a generator or a utility side. That's the difference. So in the synthetic test, the first one is direct testing in network or in the field. So in this test, basically the circuit breakers are sometimes tested for their ability to make or break the circuit under normal condition, normal load condition, and a short circuit condition in the network itself. So within the network, they are not doing separately. So suppose any live network is there, within the network, they will create a fault, or they will create this condition such a way that which will be under a short circuit will be created. So under that short circuit will be tested for both making of a circuit breaker and the breaking of the circuit breaker within the network. That's the reason it's a direct testing network is given. Okay, the test will be done within the network itself. This is done when the electrical energy is diverted to the other section of the network which are not connected to the circuit under test. If I have a two lines, okay, where I'm performing a test over here, so we will divert all the sections of the network which are not connected to the circuit. So if there are two loads, assume I have a loads here. So what I will do, I will take some other circuit, or we have a bus coupler, which to say within the two lines, I will connect the line and the current will flow from this part to this part. So this will be entirely isolated. So using your bus coupler. So then the test will be done within the network itself. But we'll make sure that so the test circuit doesn't consist of any load there. That will be the direct test in the network. The second one, direct test in short circuit test laboratories. So this will be done in the laboratory where we have a test benchmarks or test circuits where that circuit breaker test can be performed easily. So where you can see the circuit which is shown in the next slide. So this is a circuit for testing your circuit breaker with respect to direct testing in a short circuit. So here in this test, the circuit breakers will be tested at different voltages at different short circuit currents. So it will be done testing with respect to different voltage levels. It could be 11 kV or 33 kV or 66, etc. till the rated voltage of the circuit breaker. And also different short circuit current. So if you take any circuit breaker, on the nameplate or the specification, it will be given what is the maximum short circuit current it can withstand. So that also will be verified here. And the short circuit will be, this test will be done in the laboratory with this setup. So where you can see it consists of a short circuit generator. Initially, this is a short circuit generator and with a master circuit breaker. So this is the first circuit breaker which is said to be a master circuit breaker, and we have one more backup circuit breaker, and this is a making switch, or we can say the master circuit breaker here. Two circuit breakers we are making use here. In real time also we will be having this kind of circuit breakers, we will be having this kind of relays also in a power system. One used to say the primary relay or the secondary relay, or we say primary or backup relay also. The same case, whenever we have more number of relays, with respect to individual relay, there will be a circuit breaker associated with that relay. So here, the master circuit breaker, the resistor reactors and the measuring devices all will be tested with respect to the short circuit here. So the make switch initially this make switch, just I'll undo this. So once you apply a short circuit current using the generator, the make switch will be closed, which will be initiated such a way that the master circuit breaker isolator and the test devices from the source end are predetermined with respect to the time set of a test sequence controller. So here is a test device which is supposed to do the testing of that circuit breaker. So they have a predetermined time set. So what happens for particular time with respect to the circuit breaker, the test sequence will be controlled over there. And also the master circuit breaker can be tripped if the test device fails and operate properly. Okay, there is a possibility of making your master circuit breaker can be tripped if the test device fail. If this is getting fail, what happens? It may damage my test setup. In that case, your master circuit will trigger such a way that I can bypass the high voltage current easily without damaging my test system. So that is regarding testing of circuit breaker with respect to the short circuit in the laboratory. So as I mentioned, this is very important. That is a synthetic testing of circuit breaker. So where I will go with a circuit over there. I will make use of a notepad. So this is a circuit for synthetic testing of circuit breaker. So this is a voltage source, AC. I have a switch here. That is a master breaker. And have a reactor here. And it is connected with a one more switch. So just I'm giving the numbers here so that I will explain what is number 1, 2, and 3, everything over here. And it is connected to a capacitor, which is mentioned as a CC. And once again, one more circuit breaker, which is connected to a test object T here. Under test circuit breaker, we can say T. Once again, it is connected in parallel with a one more capacitor C0. It is connected with a one more inductor, and we have a 3 electrode type triggertron gap or trigger gap, we can say, which is of a 3 electrode gap. And finally, the one more capacitor, which is given with CV with potential of E. And this, the third terminal is applied with a EV. And finally, the circuit is grounded here. So the one indicates here, it's a master breaker, and 2 indicates a reactor, and 3 indicates a main switch. 3 indicates a main switch, and this is a 4 here. 4 indicates auxiliary breaker, and once again 5 is once again a reactor. 6 is your trigger gap, and have a this is your almost a 5th reactor is having LV. LV is nothing but a voltage waveform controlled choke, we can say. Voltage waveform controlled choke. This reactor is a voltage waveform controlled choke. And we have CV over here. CV, that is a capacitor charged to EV. Capacitor charged to EV to give the necessary recover voltage. And C0 is a capacitor to control the frequency of a transient recover voltage. C0 is a capacitor to control the frequency of a transient recovery voltage. And we have one more waveform with respect to this. Whenever the test is performed, we come across with few waveforms. So I will write that waveform also, then I will be explaining the entire circuit. So there are two waveforms. So the first line is indicating with a T naught. T naught is a opening of auxiliary circuit breaker. When the auxiliary circuit breaker is opened, that is a time T naught. And I have another time, that is T1. So this is a trigger gap 6 is fired. So trigger gap 6 is fired, or the flashover is occurred across a trigger gap. That is with respect to time T1. And one more time T2. So this is a auxiliary circuit breaker clears and interrupts, which clears the fault and which will interrupt the entire circuit. That is with respect to time T2. Finally, we have a time T3. T3, that is nothing but your current IB becomes 0. So I'll be writing here IB once I draw the waveform. That is a time IB becomes 0. So this is the first waveform here. And this is the second waveform. So this is a current IC, and this is a IB here, IB, and I have these two, the sum of two, I write some other color, sum of these two IC and IB, which is given by IC plus IB. IC plus IB, and these are the zero lines, x-axis we can say, and this is a transient recovery voltage across your C, across your test object we can say, transient recovery voltage. So here, we'll go back to circuit here. So due to very high interrupting capacitance, capacity of a circuit breaker, because within a circuit breaker, as I mentioned, we'll be studying in detail in the next semester. So just I will explain a few things which I want to correlate with this topic now. So within a circuit breaker, we'll be having two electrodes, or two switches we can say, or two poles we can say. One is fixed pole, another is a movable. One is fixed, one is a movable. So whenever the circuit breaker want to open or close, right? Whenever the circuit breaker want to open or close, so this movable electrode will be moving further, or it will be coming back. So when the circuit breaker is closed, the current will be flowing easily. Whenever the fault occurs, what happens? I need to bring back this electrode such a way that I am maintaining few gap within the circuit breaker. Right? I am maintaining gap within the circuit breaker. So when you try to move this electrode, this movable electrode, when you try to move far from the fixed electrode, what happens? There will be a spark occurring within the two electrodes because of very high voltage. The voltage is already, the current will be flowing from the circuit here. When you try to break the circuit, what happens? Very high amount of current will be flowing here. That will give rise to the spark within this circuit breaker. So you might have observed that the spark, whenever you try to open the switch or close the switch, the spark will be seen. In the real-time system also, the spark, the arc will be present there. So the arc will be present over there. So to extinguish this arc, we make use of a medium. It is your, whether it could be SF6, right? Or we can make use of a nitrogen, or It could be your normal air, right? Some other gases. So these gases will be made used to, they will flow this gas with a high pressure so that it extinguish this arc, so that I can easily open my circuit breaker. I can move the movable contact away from the fixed contact. This is how it has supposed to do. So because of that reason, we say that the circuit breakers will be having high interrupting capacity, because within that, whenever the arc are produced within the circuit breaker, it will be having a very high capacity. So I need to have the rating of a circuit breaker such a way that, so based on your short circuit and the rated voltage. So your single source should provide the required short circuit and the rated voltage. So whatever the source I am using here, so this should be sufficient to give that much of short circuit current and that much of a rated voltage. That is the first condition for doing this test. And the effect of the short circuit is obtained on the basis of your recovery voltage, which is shown in the second waveform over there. So when your auxiliary switch, that is a 4, auxiliary circuit breaker 4, and the test breaker T, these two are closed. I'll be closing here. When the auxiliary circuit breaker and the test T is closed, the closing and making switch S1 causes the current to flow through the circuit. Whenever I close this 2 from the first circuit breaker, the current will flow through the circuit. At some instant of time that is given with respect to here at the T0 time, so the test circuit breaker T begins to operate. So this T will begin to operate, and the master circuit breaker 1, becomes ready to clear the generator circuit. At a time T1, which is shown here, at a time T1, just before the zero of a generator current. If you observe that, so this is my generator current which is flowing, which is going to become zero after few seconds. Before that, your master circuit breaker T1 will start here, which clears the fault or which clears the generator circuit. So it will clear the generator circuit before the IC becoming 0. So that is going to happen here. And your triggering gap G, this one, the 3 electrode gap G will be closed, and the high frequency current from the discharging capacitor CV also flows through the arc. So current will flow through the arc with respect to discharging capacitor CV. At a time T2, when the generator current becomes 0, almost you can see here, the blue line is 0 here. When the generator current is 0, the circuit breaker 1 clears the circuit, leaving only the current from CV. So hence the high current will discharge from this circuit. So only that current will be available here. That is the current from the CV is IV. The current in the capacitor CV is IV. Only that current will be present here. So which have to require the rated change of current at a 0 flowing in the circuit breaker. So this is a required rate of change of current at a 0 flowing current in the test circuit breaker. Here in this current, the current flowing in this circuit will be 0, almost a 0, because IC has become 0. Now only this current will be acting here. At the 0 of this current, the full test voltage will be available across the test circuit. Where the current is 0, the maximum voltage will be applied across your test object. Here, the maximum voltage will be applied where the current is 0. So it is important to see that the high current source is disconnected. When you are applying a high voltage, this source should be disconnected, and the high voltage source should be applied absolutely at that precision of time. That is a additional arrangement we need to do within the circuit. When the current becomes 0, we remove this current source generator and we apply a high voltage source to the circuit breaker by means of your auxiliary circuit breaker. That's the reason we make use of a auxiliary circuit breaker within the circuit, that is a C4. This will be used to disconnect here. If you open the circuit breaker, then the current flowing here will be disconnected. So this test will be connected to another voltage source which is not shown here, which has been given just in the explanation. So this is regarding the testing, synthetic testing of a circuit breaker. Okay, so I will stop here. We'll continue. A few more tests are there with respect to the circuit breaker and isolator. So that is a composite, unit test, and testing procedure and asymmetrical test. So these four I'll continue in the next class. Okay, we wind up.